everyone!
Today, we are going to compare and contrast simple paging and simple segmentation. The aim of this lesson is that you will be able to understand the usage and differences of simple paging and simple segmentation. Okay, let's start with the definition of simple paging first.
So, what is simple paging?
Simple paging is a memory management scheme that eliminates the need for contiguous allocation of physical memory. Paging refers to retrieving processes in the form of pages from secondary storage into the main memory. The use of simple paging is to reduce fragmentation and efficiently utilize the available memory. The paging technique divides the physical main memory into fixed-size blocks that are known as frames and also divide the logical secondary memory into blocks the same size that are known as pages.
So, how simple paging works?
Let me show an example on how simple paging works. Firstly, we will load the P1 partition into the main memory. The position will not seem like the secondary memory. This is because in the main memory we have the space that occupied from others processing goes like P2 and P3. We will load it into the main memory. Let's see advantages of simple paging. First is paging reduces wasted space due to fragmentation. Second is it simplifies memory allocation, as each page can be located anywhere in physical memory.
Third is flexibility. Processes can be easily swapped in and out of memory, enhancing multitasking capabilities.
It provides a layer of protection and security. Each page can be assigned its own protection level, preventing unauthorized access and ensuring that sensitive data is kept secure. Now let's talk about disadvantages of simple paging. One is pages are fixed in size. And if a process doesn't use all the space in a page, the unused space is wasted. Every process needs a page table to map its pages to physical memory. These tables take up extra memory. Accessing memory requires looking up the page table first, which can slow things down.
Now, what is simple segmentation?
Segmentation is a memory administration approach used in operating systems that divides memory into multiple sized segments. Each segment are stored in a table called a segment table. Segment table is stored in one or many of the segments. Simple segmentation is used to prevent memory fragmentation by dividing a process into multiple segments, each loaded into memory at runtime.
So, how simple segmentation works?
In simple segmentation, frames are in main memory and pages in secondary memory. Data is loaded from main to secondary memory, where variable-sized segments are divided into variable-sized pages. Segment positions are not fixed and can change. Advantages of simple segmentation is unlike paging, segmentation does not suffer from internal fragmentation since segments are of variable sizes. Segmentation provides a higher degree of flexibility than paging. Segments can be of variable size, and processes can be designed to have multiple segments, allowing for more fine-grained memory allocation. Segmentation allows for sharing of memory segments between processes. This can be useful for inter-process communication or for sharing code libraries. Segmentation provides a level of protection between segments, preventing one process from accessing or modifying another process's memory segment. Let's see some disadvantages. First is external fragmentation. As processes are loaded and removed from memory, the free memory space is broken into little pieces, causing external fragmentation. Using a segment table can increase overhead and reduce performance. Each segment table entry requires additional memory, and accessing the table to retrieve memory locations can increase the time needed for memory operations. Segmentation can be more complex to implement and manage than paging. Due to the need for two memory accesses, one for the segment table and the other for main memory, access time to retrieve the instruction increases.
So, what's the difference between simple paging and simple segmentation?
In paging, the program is divided into fixed or mounted size pages, while in segmentation, the program is divided into variable size sections. Then for the paging operating system is accountable, but for segmentation compiler is accountable. In paging, it is faster in comparison to segmentation, while segmentation is slow. Then paging could result in internal fragmentation, while segmentation could result in external fragmentation. In paging, the logical address is split into a page number and page offset, while in segmentation the logical address is split into section number and section offset. Then this protection is hard to apply in paging while easy in segmentation. In conclusion, simple paging and simple segmentation are both memory management techniques with distinct advantages. Simple paging eliminates external fragmentation and simplifies memory allocation, but can suffer from internal fragmentation. Conversely, simple segmentation aligns more closely with program structure, offering better support for varying memory sizes and protection, but may result in external fragmentation. Each method's suitability depends on the specific requirements and constraints of the system in use. Thank you for watching.